leverage the case could have. Another measure of influence is what's called Cook's distance. And so you will see people talk about leverage. You will see people talk about Cook's distance, particularly if they get to, well, we excluded cases because their Cook's distance was greater than. You might read someone doing that. And the Cook's distance, kind of here's the formula. It's a global, kind of at a conceptual level, it's another global measure of influence. So it's not telling you which regression coefficients are getting messed up, but it's telling you that a variable, that a case is having an influence. It is influencing, it does look at, because it's got the residual in it, it looks at the influence based on both x and y in this case. So Cook's distance is looking at real impact on the regression model versus the potential impact that it might be having. Unfortunately, there's like no real criteria. How do you know something's big or not? But you could look at a range of, you look at Cook's distance for all of your cases, not all the variables, all of the cases. And again, if a couple stand out, it tells you that those cases are having more of an impact on the regression coefficients, on the regression model. You can kind of think of, in a way, this combines all of the, right, it's not looking at each of the individual regression coefficients, it's kind of looking at all of them and saying, how are you having an influence on the overall model, kind of on the gestalt of the regression analysis. DF beta, which I personally like, is a little different in that it's now looking at each individual regression coefficient, which is why some people don't like DF betas. You are looking at what happens to each regression coefficient as each person is deleted from the analysis. So if you've got, if you got 100 subjects, you perform, the computer does it for you. It performs 100 multiple regressions, and for each regression, it says, okay, I'm dropping Kavanaugh, and I'm going to look at the regression, what happens to the regression coefficients for each regression coefficient when I drop Kavanaugh, and that's going to be the DF beta. For the intercept, how much did the intercept change? So it looks at the original intercept, and then the intercept when we dropped Kavanaugh. And that's that DF beta for the intercept. And then for X1, it does the same thing. It looks at how every regression coefficient changes when Kavanaugh is dropped from the analysis. And then it does it for Chapin. And it does it for Toby, and on and on and on. Okay. The trick is, so you can, one of the problems is that's an awful lot of numbers. It's kind of, in that sense, there's a balance between Cook's distance, which gives you one number for every person, that kind of summarizes all those DF betas. So, you may want to kind of go back and forth between the two. If you've got a big Cook's distance, can you, on a record, are there specific regression coefficients that seem to be in play for that person? Or is it just kind of across the board? There's no criteria because you're looking at differences in the standardized coefficients. How big it is, just looking at that number is hard to evaluate. There's no kind of, how do you determine something's influential? So you can actually standardize the DF betas, and these are pretty standard output you can request, is the DF beta and the standardized DF beta. And that just takes sure it divides each of those individual DF betas by the standard error that you'd estimate for that coefficient for that person. So now you've basically converted them into, theoretically, standard scores, but they're more standardized, but they're not Z-scores. We should be clear on that. The criteria, it's still very squishy. You'll see some say that the anything with a standardized DF beta above 2 should be looked at. Some will say 1. I think you see this number a lot, 2 over the square root of n for small samples, which can tell you, for small samples, if your sample's really big, they're all going to be bigger than that. But it's kind of hard to, it's really something you need to look at the totality across all the data. What sort of pattern do you see in these? And not just get into dropping cases willy-nilly. Talking about dropping cases willy-nilly. Going to get right there. So kind of some final comments on influence and outliers. Again, just because something's an outlier doesn't mean it's necessarily influential. Influence is, if something is disproportionately influential, it is a problem. In the sense that, or it's probably a problem. Just because it helps your regression, makes your results stronger, isn't a good, you may like it, it may make us happy, but it's not a good thing if your regression equation is getting drastically pulled by 1 or 2 cases. It is a problem. It's not just a problem when it hurts you. So don't ignore it if it exists. I have unfortunately been in the sad world, because I like looking at interactions. More times than I can remember, I've found this phenomenal interaction that, wow, this is, when you put these 2 things together, behavior really skyrockets, or these 2 things together and the kids are doing awesome. And then I look at the influence analysis and it's all being driven by 1 or 2 cases out of 400. There was one time, it was literally 1 case. I dropped 1 case and my beautiful result disappeared. And I never published it. It was vapor. I just, 1 case. There will be people that will publish it, and they'll just never do that analysis. They'll never come back and point out. You report the regression coefficients. You make nice little charts. People won't notice.
People won't replicate it.
It'll never get replicated. Did you just see the big news this last week? I think we probably mentioned in the past. I digress a little. A crisis going on in the behavioral sciences of studies not replicating. There's been a couple attempts over the last several years of replicating 20 top studies here, 15 top studies there, and they don't replicate. Consistently, half of them will replicate. You often find, sometimes it's less.
The recent one.
This recent one. What was interesting, this recent one, so this group.
No, what I mean, those are the recent phenomena that people thought they were huge.
Oh, yeah.
And then
it gets a lot of news coverage, gets grant money thrown at people, all sorts of stuff. So this study, people would then come back and say, well, that's because they did it wrong. You didn't do what they did, so it's you tried to replicate it, but it's your fault you didn't replicate it. It's nothing wrong with the theory, or your population was different than their population. That's why. People would try to explain, or at least some people would try to explain it away. So this was a big group internationally across multiple countries with multiple populations, multiple researchers looking at 40, was it? I can't remember, maybe 24. Some number of solid, widely regarded, hot recent findings that people have been all excited about. And just like we found over and over again, half of them never replicated. And what was fascinating with it was, if something replicated, and it gets rid of all the complaints, because what was interesting is, if it didn't replicate, they said it generally didn't replicate for any of them. So it wasn't just one person replicating. You've got all these international teams trying to replicate the same study. If this phenomena didn't replicate, it didn't replicate anywhere. If it did replicate, it replicated everywhere. So it gets rid of the issues that, well, it's just because you did the study wrong. Well, because now you got to say it's not just you, it's you and you and you and you and you and you. Or it's just your population's wrong. It doesn't work with that group. Well, it doesn't work with that group or that group or that group or that group. No. So it's a beautifully it's going to be hard to ignore study. That there's these fundamental replication problems. And it's not just because of the convenient reasons. It's because we're hyping stuff, we're publishing stuff that is just flat wrong. One of the reasons we're publishing things that are just flat out wrong is I get a result that's based on 400 kids, but it all comes down to one subject. And it's hot, it's sexy, it's a phenomenally cool interaction. I get it in the top journal, and it's complete bunk because I either never looked at the results, or I looked at the results and just didn't tell anyone, which happens probably more than it should. People know I told you I reviewed the article. Did I tell you that story? I was reviewing an article, and the authors, I think I could say this. The authors did not clean their manuscript when they sent it to us. So there was track changes and comments. And in the if you had to pop it up to ask for the comments, but if you popped it up and asked for the comments, right there in the comments is one author to another author, should we point out the fatal flaw in blah, 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 or hope no one notices? I do not kid you. Do we point out the fatal flaw or hope no one notices? Well, I can tell you what they did is they hope no one noticed. But not cleaning the comment. It was beautiful. So pointed it out to the editor rejected the paper. And pointed out to them.
Read your own manuscript.
About 6 months later, completely different journal. I'm reviewing for a different journal. I get a paper sent to me. I open it up. It's the same paper, unchanged. The same stuff. This time though they cleaned it. Oh, I was laughing. Oh, it made my week. It was wonderful. They've cleaned out the comments. Do we point out the fatal flaw? But the fatal flaw was still in there, and they didn't tell anyone. That's why half the studies don't replicate. Or that's one of the reasons why half the studies don't replicate. Because we're not as pure and ethical and high and whatever as we try to tell ourselves in our ivory towers. Off camera, there's other stories I could tell you.
As a reviewer, do you have to report anything like that?
Oh, this second one was interesting because I was wrestling with, I'm privy to information I should not have access to. So I went to a senior colleague, who his career had edited numerous journals. He'd served as an editor all over the place. I asked him, what should I do in this case? Do I reject the paper? I'm going to reject the paper. I'm going to vote for rejecting. Do I tell the editor that I know that there's this fatal flaw that they're not telling us? Or, my editor colleague told me, oh, you tell the editor. You let them know.
It's your responsibility.
So, but we digress. But actually, that's a very important point. Just don't ignore it. Even if it helps you. If it's a problem, it's a problem. Because you've got good, people like to do this when they get bad results. It's like, okay, who can I drop? I got to find some rationale to clean up my results. Where's the subjects that are messing up my results? Who can I drop and make something work? How do I make a silk purse out of this sow's ear? So people will do all of this stuff when things don't work the way they want, but they don't do it when the things do work the way they want, and they end up publishing papers in top journals with an N of 400 and one case making their whole interaction. So,
Type 1 error.
I tell you, it hurt because it was beautiful. I was so excited for several days. I was so excited. I thought, man, this is like child development stuff. This is, and then it's like, well, you know what? I should check just to make sure. And now it's in my never published bin. So part of kind of along that theme, don't drop cases willy-nilly. Don't just because something's an outlier, something's got leverage, something's influencing your results, don't just drop it. Try to understand what went on. Is this all the kids misinterpreting joyriding or misinterpreting Caucasian, making a smiley face on their bubble sheets, showing off to their friends, you go look at how bad I am. Take a look at the data, try to understand it. Along those lines, another paper I reviewed was the authors were kind of describing what they did, and they had, I think it was like 7%, 8% of the sample. They said 8% were outliers, this model didn't fit 8%, we dropped them from the analysis. And I came back, and actually another reviewer came back and said, you can't just drop 8% of your sample without, take a look at them. Take a look, see, was there a problem? Was there anything about those 8% that explains kind of why what happened? And it took them a bit because they must have gone back to their raw data and looked at it. They came back. It was fascinating. I was looking at college-age students. They came back and said, we looked at the 8%. And in that 8%, it was like a sample of 1,000, 1,500, a lot of college students. In that 8% was almost every single gay or lesbian student in their sample. I don't know what was going on, but it's fascinating that whatever their model was, looking at like self-esteem or something with college students, it was some warm, fuzzy, social sort of thing outcome. Whatever it was, worked great for students who weren't gay or lesbian. But it did not apply to gay lesbian students. And that's what we came back and said, great, we accepted it. We said, now you can explain. Now you can justify why you dropped them. And here's a great future research someone needs to do. This model works for those students. It doesn't work for them. Why? What would we want to understand? What works for their self-esteem or whatever? Because it ain't that. Here's an area for future research. Made it a much better study. Much stronger study. So don't just drop willy-nilly. Also, you can end up with a non-existent population. If you end up dropping, you'll see studies will drop 10 or 20% of the cases for missing data and whatever. Then who are you talking about anymore? I mean, think of this case. If you're talking about college students, but we don't have any gay lesbian students. What if it was another 15% of you don't have any this or that or whatever at the same time? You end up with a population you can't even describe anymore. Look at other alternative solutions. If you've got problems, and you can make a more complicated model to start to take that into consideration. Okay, we know this equation. This is what we're back to structural equation modeling. Is beautiful for that. You can design models, or call it kind of these multi-group models. We're able to say, males, I think this is going on, and females, I think this is going on, and this is going to be different between the two. You can come up with more complicated models that let you start to develop alternative frameworks for those where it doesn't fit, where you're ending up with residuals or outliers. So put some work into it. Don't get lazy and just say, they were outliers. We dropped all of them, and they lost the most interesting thing. It was actually a boring paper. It was a much more interesting paper once they were able to point out this didn't work for our gay lesbian students. It's like, wow, that was cool. Okay, other things to keep into consideration.